Hi grade 12 students, I've made this video, the last video before your exam, to go over some of my top 10 tips for the relations and functions unit. So what I've done is I've found some old exam questions that demonstrate why these tips are a good thing to know. And if you're a little foggy on some of the things, or if you're reviewing, hopefully everything comes back to you after watching this video. So we're going to see all these 1 to 10 items come up as we go. So I'm just going to go to the very first question that I found. And right here on this page, this will be a page we're coming back to often, because this helps us with tip number 1. You need to know the basic shapes of graphs. You need to know the quadrants and the domain and range and the degree. So looking at this question, it says circle the graph below that best represents a cubic function. So if you know the basic shapes, the correct answer will be just jumping out at you. And if you need to look at a reference sheet, you look at a reference sheet. Let's find out what the basic shape for a cubic function looks like. Okay, so here we see the word cubic. Cubic functions are right here. Here's an example of an increasing and a decreasing cubic function, and this is the classic shape. It doesn't have to have as much of a bump, I like to call it, but it's actually called 2 turning points. And we definitely can go back to this question, and without much difficulty, we can tell that this is the right answer. You can also figure out what A is, what B is, and what C is. They should look like the basic shapes of 3 others. So that might be a good idea for you to pause this video, look at your reference sheet, and make sure you know those, because maybe on your exam they're not going to ask you cubic, maybe they'll ask you quadratic, or maybe they'll ask you exponential. Next question. Okay, why is it important to know the quadrants? I've highlighted the word quadrants here from tip number 1, because we're going to see sometimes wording end behavior. Okay, and we see them talk about quadrants 3 to 1. If the end behavior of a graph of a function extends from quadrants 3 to quadrants 1, then the function behavior is and you have 4 choices. So let's go back to our reference sheet. Remember, it was 3 to 1. Okay, did linear go 3 to 1? Or let's just find, first of all, I'm going to erase all my previous scribbles, and I'm going to see which ones go 3 to 1. This one happens to go 3 to 1. This one goes 2 to 4. 2 to 1, 3 to 4. 3 to 1. 2 to 4. 2 to 1. 2 to 1. Sinusoidal is different. And then, I don't have it marked on here, but I should. This would be a good addition to add to your reference sheet tonight, something that got missed. Let's use a thinner pen. What quadrant is this? This is quadrant 4. And this is quadrant 1. And this is quadrant 1. And this is quadrant 4. So as you move left to right, you describe your end behavior. So back to our question, we need more information because there are 2 functions that go 3 to 1. One is linear, one is cubic. Both of them are increasing. Do we have constant, quadratic, cubic, sinusoidal? Well, they didn't make it hard for us. They didn't put both linear and cubic. They only put the cubic one. So that is the answer that we should select, C. And it was pretty easy with our reference sheet and having the quadrants labeled on them. Moving on to more tips, you should know the x-intercepts and the y-intercepts, the location of those two features and the number of possible intercepts. So on our reference sheet, we are going to look on the y-axis and the x-axis to see how many times this line crosses. Okay, and when we get to quadratics, I'm pointing out to you here, I'll get my highlighter, I'm pointing some things out to you. Those are the x-intercepts. Okay, I pointed out the x-intercepts. Over here, in our little chart of information, we often mention what value in the function represents the y-intercept. Y-intercept, y-intercept, y-intercept. Okay. And you can also find these with Desmos. But let's look and do some true and false. It's always good to evaluate every statement as you're doing a multiple choice question. So we are going to not just try to find the right answer, we're going to look at every possible option and make a judgment on whether it's true or false. A linear function has only one y-intercept. Is that true or false? And I'm looking here, there is only one y-intercept for a linear function, so that is true. A quadratic function must have two x-intercepts. Well, number of x-intercepts, 0, 1, or 2. So it is possible to have a quadratic function that does not cross the x-axis. It could have the vertex above and not cross. So I think we've identified the one option that is false. This is false. You can have 0, 1, or 2 x-intercepts in a quadratic function. An exponential function has only one asymptote. Now an asymptote is where a line starts to approach but never crosses that point. And so that is actually true, even though that term is not on your reference sheet. We can see that an exponential function, this one here, will be coming close to 0, but will never actually be 0, and that's an asymptote. And same thing here, never actually is 0. And a logarithmic function has a range that extends from negative infinity to positive infinity, and that is true. We see this arrow pointing and going all the way down, so it's going to negative infinity, and pointing all the way up is going to positive infinity. And the same thing happens here, positive infinity up, negative infinity down. Okay? And so this one is true. Regardless, we found our correct answer on the second statement. This one is the false one. All the other ones are true. All right, we know we have to do a lot of work with Desmos. So tip number 3 is solving for an x or y value in Desmos. And tip number 4 is adjusting window settings. So we're going to do both in this example. A golf ball is struck from an elevated platform at a golf course. The height of the golf ball above the ground is modeled by the equation. We can type this into Desmos. You can type it in exactly as you see it, using the h's and the t's, or you can use y equals negative 5.33 x squared. Make sure you know how to square a value, plus 31.33x plus 4. Okay, let me just adjust that. I didn't say plus 4 there. Now it's working. And I'm going to go right to tip 4. How do we adjust our window settings in Desmos? We can't see all the main features of this graph. We just see skinny little lines going up and skinny lines coming down. And I want it to look nicer than that. So we always go to our graph settings. Can you see the wrench looking tool? That's what we're doing. And I've often told students to imagine that you're trying to cut out this image on a piece of paper. Where would you be cutting? I might want to cut off here at the -5 and the 10. On which axis is this? This is the x-axis. Okay, so we go to the graph settings. You go to your graph settings. We just talked about adjusting the x-axis so that the lowest value that we see is -5. So this goes from low to high. And if you make a mistake, that's fine. Okay, just adjust it again. Now we have a graph that goes from a low of -5 to a high of 10. That's perfect because we get to see everything plus a little extra room on each side. But we have some problems here with the y-axis. The main problem is we can't see the top of our graph. So right now our high point on the graph is just above 15. And I can't tell you what the exact number to pick is, but I can tell you that you should try to make it better. So trying to make it better is increasing this number. Okay, I increased it to 20, and what do you think? Does it look great? Not yet. Maybe I should have done 50. Okay, well, 50 was almost there. In fact, it will work, but I want it even nicer. So 50 was very, very close, so let's go with 60 next. Much better. I can see all the main features of the graph. I can see where it crosses the x-axis, and I can click and have that. If you click and don't just hover over it, it will stay there displayed on your screen. If you click, it'll stay displayed. Click, it'll stay displayed. There's even another x-intercept here. Okay, so we have been able to adjust window settings in Desmos, and we've been able to solve for what they were looking for. Going back to our question, it says using the graphing calculator or graphing software, determine the maximum height of the golf ball, and the maximum height of the golf ball was 50.04. And then it's a good idea to read the question, 50.04 what? 50.04 yards. And that would get you full marks on that answer. The other thing that this question didn't do is it didn't, and we could maybe make it a little more complicated. We could say, how high is the golf ball going to be at exactly 5 seconds? Okay, so we can tell that it's still in the air at 5 seconds because it takes 6 seconds for that golf ball to come down and hit the ground, 6.003, but rounded to 2 decimal places, 6.00. So at 5 seconds, it's going to be approximately this high off the ground, which again, approximately we can see is somewhere between 20 and 30. But we have to be more exact than approximately. We have to know exactly where it is. So when x is 5, you just type in x is 5. It adds a new vertical line, and you click and you hold it so that this is displayed, and you can write down your answer, 27.4, and you would have to say 27.40. Because we do need 2 decimal places. If it only has 1, you have to put a 0 after it. Let's try another one. Let's try what is the height of the golf ball. At what 2 times is the golf ball at a height of 20 yards? So we have to put in y equals 20, and the golf ball will be at exactly 20 yards off the ground at these 2 times. So it's really straightforward being able to do tip number 3, which is solving for an x or a y value in Desmos. Just wanted you to have this last little chance to review it. Tip number 5. Being able to do regressions in Desmos, except for sinusoidal regressions when you have to do those in the TI-84 calculator. There are instructions if you totally blank tomorrow on the exam. There's instructions on how to do this on your reference sheet. And then I thought I could add into this question also tip number 9, describe how to understand how to describe an appropriate domain and range. So with this question, we are being asked to do a regression, and often they tell us what kind of regression they want. So it says here, determine the logarithmic regression. So what you're going to do when you see that you're going to do a regression is you make sure you know what your log formula is. And you can find that in two places. You can find it on your reference sheet or on your formula sheet. And so the way I have recommended for students to do this is so I've got my formula sheet out. I'm going to type in exactly what my log function looks like. Some of you might want to do a shortcut and try to put everything in one step, but I'm going to do it in two steps. This is step one. Type exactly what it looks like. Step two is make my adjustments. I have to put a notation of a 1 with the y and any of the x's. And I only have one x in this formula. And I have to change my equal sign to a tilde sign. Okay, step 2 is done. Step 3 is to add a table. I now need to make my adjustments to my table. Make the x a 1, make the y a 1, and then I need to start typing. I'm going to pause, and then I'll come back with all my typing. All right, I'm back. I've got all my typing done. I have now made a regression from Desmos, and really good idea at this point to just double check that you haven't done any silly typos. If I've made a typo, I'm looking, I can't see anything that's jumping out at me. But we now need to write down our equation. That is one of the next steps. So I'm just going to get my pen going here. Make sure you can see everything you need to see. So remember your formula was y equals, and then you had to write down a value for a. So our value for a is 6.44 rounded to 2 decimal places. And you have to go plus, and you have to write down a value for b, 5.55. I had to round the 4 up to a 5. And then ln x. And that gets you 1 mark. Determine the logarithmic equation that best represents the data. Okay, you would lose marks. Here's where what we don't want to do. I'll do it in red because red is wrong. We don't want to put any of this. You've done all this work to get your answer, and you've added in the Desmos requirements like the tilde and the notations on the 1. Don't do that. You only had to use Desmos to get these 2 answers, and then once you got those answers, it should look just like the formula on your formula sheet with the equal sign and a regular y. And just a caution, don't copy it from the screen, copy it from your formula sheet. And then understanding appropriate domain and range. We've got a follow-up question here. Actually we have using this equation, predict the average height of the plants on the 30th day. You just saw that in the previous tips. So you would decide whether 30 is an x value or a y value. So which one looked like it had anything to do with days? Which column had to do with days? The x column had to do with days. So we have been given an x. You go to Desmos, you put in x equals 30, and we have to find it. And you can adjust your window settings, or you can scroll, and there's your answer, 25.31. Predict the average height of the plants. I'm going to predict that it's 25.31 centimeters tall. The logarithmic function can represent the average height of plants, but it has limitations. Explain why the domain and range is limited in this situation. So going back here, why would the days be limited? Can you have infinite days for the growth of a bean plant? You cannot. One thing you could write down as a possible answer is the domain is restricted because the bean plants don't have an unlimited lifespan. They will eventually die. And the range is limited because for a couple of reasons. You can't have negative height, and you can't have unlimited growth. This is not going to be a plant that will grow and grow forever and ever. It will eventually reach a maximum height. Just like humans will reach a maximum height, we don't get to continue growing into our adulthood, so bean plants are no different. So just be reasonable, just use some common sense. I'm going to end this video right now and call this part 1 because I'm at the 20-minute mark, and then I'm going to come back for part 2 and finish off my tips.